Hi, in this video we will do more examples for derivatives of the natural exponential function. Recall that the derivative of e to the power x with respect to x is e to the power x, and the derivative of e to the power some function is the derivative of that function e to the power that function. So here, let's start differentiating these functions. This will be the, first apply the sum rule. And this will give us derivative of e to the power x is e to the power x. Derivative of e to the power 3x is derivative of 3x times e to the power 3x. Plus derivative of x squared is just 2x. And that gives us e to the power x plus 3e to the power 3x plus 2x. The other function is this guy. So the derivative of e to the power x squared plus 3x is derivative of x squared plus 3x times e to the power the same function. So this will give us 2x plus 3 e to the power x squared plus 3x. Derivative of e to the power x plus 3x to the power 5 prime. Well, this is the general power rule, so it will be 5, the power derivative of the function, times the e to the power 3x to the power 1 less of that function. And this guy here, this is sum of e to the power x plus 3x. So the derivative would be derivative of e to the power x, which is e to the power x, and derivative of 3x, which is 3. So we have 5 e to the power x plus 3, e to the power x plus 3x to the power 4. And this one, we have the quotient rule, derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator. And then the denominator to the power 2. This now we differentiate one by one. E to the power x plus 4. The derivative would be e to the power x plus 0. So I just write that. Minus. Here we have derivative e to the power 3x plus 1. This will be derivative e to the power 3x, which is 3 e to the power 3x. So it will give us minus 3 e to the power x, e to the power 3x times e to the power x plus 4. You can multiply and simplify this numerator. I won't do it here, but you have to be able to apply those kind of. So expand this thing first and then simplify, see what you get there. Okay. In the second example, we will find an equation for the tangent line. Remember, we need a point. In this case, it is, well, 1, f1, which is 1 and e to the power 1 minus 1 plus e to the power 1 negative 1 squared plus 1 over 2. E to the power 0 is 1, and e to the power, the other one is e to the power 0, 2. So you have 1, the first component. The second component is 2 over 2, which is 1. And for the slope, we need to find f prime at that point. So this will be the slope. So let us then find f prime of x. Okay. 1 over 2 is just a constant, so we can apply the constant rule and just take it out. And then these are sums of two functions. we can differentiate each one first and then add them. And that will give us half of, this is derivative of x minus 1 e to the power x minus 1 plus derivative of minus x squared plus 1 times e to the power minus x squared plus 1. And that gives us half of x minus 1 is 1, the derivative of x minus 1 plus this guy here, it will give us minus 2x plus 0. So I'll just write minus 2x e to the power minus x squared plus 1. And now f prime at 1, we have to evaluate the function at 1. Minus 2 times 1 e to the power minus 1 squared plus 1. This is half of e to the power 0, 1 minus 2 times 1 times 1, which is, so this will be negative half. We have the slope, we have the point. We write this, an equation for the line by this. So on the right hand side we have negative 1 over 2x and plus 1 over 2. I take this one to the other side also. You get y equals to negative 1 over 2x plus 1 over 2, which is 3 over 2. That's an equation for the tangent line at x equal to 1. Okay, higher derivatives are functions which have somehow exponential functions. So here what we have, f prime of x, this is, well, e to the power something, the derivative. So we have to find derivative of that something. And then this guy. Derivative of minus x is just negative 1 times this. And the second derivative is minus e to the power minus x prime. Negative sign comes out. And we have the derivative of e to the power minus x. We just found it. It is, well, this negative sign comes from here. But the derivative of e to the power minus x is minus e to the power minus x, as we computed above. So this is plus e to the power negative x. We apply another time, but then you notice that, oh, this is the function itself. So differentiating the function itself will give us f prime again. And this. You see that in general, this derivative is going to be either plus or minus e to the power minus x. Yes. But when is plus, when is minus? So you see, if we are differentiating odd number of times, we get negative, and even ones we get positive. And that can be generated by negative 1 to the power n. Negative 1 to the power n will give us a negative sign when n is odd, and when it is even, it will give us positive. Very nice. For this one, f prime of x is, well, we are differentiating e to the power x squared, and that is x squared prime e to the power x squared. This is 2x e to the power x squared. The second derivative is 2x e to the power x squared prime. We need now product rule. Yes, so the derivative of first one times second one plus the first one times the derivative of the second one. Derivative of 2x is 2 e to the power x squared plus 2x. Well, derivative of x is, oh, there's a derivative sign here. Derivative of x squared, we just computed here, yes? Appeared again, so we get 2x times e to the power x squared. And as you can see, I can factor out e to the power x squared, and the remaining things will be, there's a 2 here, and there's 2x times 2x there, so it will be 2 plus 4x squared. We can differentiate one more time. again the product rule comes in. And very same step, so it will be 8x from there, e to the power x squared plus 2 plus 4x squared. Again, the derivative of e to the power x squared is 2x e to the power x squared. This is something we computed. Actually, I can now factor out e to the power x squared. Here I have 8x and 2x times 2 will give us another 4x. So together it will be 12x plus 2x times 4x squared. This is 8x cubed. That's the derivative of that function, the third derivative of that function. In implicit differentiation, we can have equations which have the exponential, the natural exponential function, but always the rule is the same. You start differentiating the equation, both sides of the equation. So here we have e to the power something. We have to find the derivative of that something times e to the power same thing, and derivative of x with respect to x is 1. Now here we have product rule, so it will give me derivative of first one times second one plus first one times the derivative of the second one, and everything multiplied to e to the power xy, which is equal to 1. Complete the differentiation. Derivative of x with respect to x is 1, so I have y, and then here's x dy dx times e to the power xy, which is equal to 1. Very nice. And what does this give us is nice, that you see this is an equation for dy dx. We need to solve it. First thing is take this to the other side. This will give us y plus x dy dx is 1 over e to the power xy. And then the second thing is take y to the other side. So it will be x dy dx equals, by the way, this is in the denominator. I can bring it up, write e to the power minus xy minus y. And then the last piece is divide this x to the right hand side. So it will be e to the power minus xy minus y divided by x. That is the derivative of y with respect to x using implicit differentiation. Okay, and this one again, same story starts here. Derivative of both sides. I applied the sum rule already, and this gives us product rule again. Derivative of x is 1. Oh, this is e to the power 1 times e to the power y plus x times derivative of e to the power y will be the derivative of y e to the power y plus, then we have derivative of first one times second one plus first one itself times derivative of e to the power x, which is e to the power x. This is equal to 0. Now we have e to the power y plus, well, x e to the power y dy dx plus dy dx e to the power x plus y e to the power x equals to 0. Now solve it for dy dx. Take the terms which doesn't have dy dx to the right hand side, minus e to the power y minus y e to the power x, and factor out dy dx here. So dy dx is x e to the power y from the first term. The second term has only e to the power x. And then divide both sides by the factor of dy dx, which is, this is what we get for the derivative of y with respect to x using implicit differentiation. Last piece here, we are differentiating with respect to, well, we have x and y, two functions of t, and we have a relation, this equation in x and y. We have to find the related rates. So in the related rates also you differentiate both sides with respect to, you differentiate both sides, but this time you have to differentiate with respect to t, the third variable. That's the difference between the related rates and how we solve related rates and the implicit differentiation. So this gives us dt e to the power x plus derivative of e to the power y equals to derivative of this guy here, 3 x plus derivative of e. Okay, so you see, when we had the function e to the power x and we were differentiating with respect to x, it would give us e to the power x. But now we are differentiating with respect to another variable. It means that this x now you need to take it as a function of t, and then you will get dx dt times e to the power x. And as you can see here, then we have dx dt e to the power x, dy dt e to the power y equals to dx dt. And look, d dt of e to the power t is e to the power t. But here, what we have derivative of e. What we have is derivative of e. It is a constant. Derivative of constant is always 0. Now plug in values. What are the values? X is 0, y is 1, and dx dt is 3. So we have 3 e to the power 0 plus dy dt. We don't know what is that. E to the power 1 equals to 3 plus 0. So that gives us 3 dy dt times e plus dy dt times e is equal to 3. These two cancel each other and we get dy dt times e is equal to 0. I can take the 3 over there and they will. Well, that means that dy dt at that moment, at that point, is 0. And that's how we find this related rates. Yeah, so you need to know all the steps to differentiate, and also different situations in which differentiations comes in. And also you need to know these two new rules, how to differentiate the natural exponential function.